Nowadays, how much data is generated for a minute? Slide. Sir, screen full screen. So how much is generated data in a single minute? Data I'm saying, not the size of the data. See here first, YouTube. In a single minute, 500 hours of video is uploaded. 500 hours of video. And this is webinars like what we are conducting now on online. So 856. So we can assume 69 million WhatsApp messages. So these are all things we need to save it. Twitter. Okay. Now photos, Google Photos are nowadays handheld devices are more generating more data. So this WhatsApp will be used in handheld device, that is mobile, Twitter, Gmail and photos. Okay. Now if you convert this into the value, so how much size? So in a single minute 1736 terabytes of information is generated. Terabytes 1736. So is it possible to handle these huge amount in a normal computer? You can see here. So video streaming. So 513 TB per minute. Okay, if you multiply into 1000, it will be converted into the GP. And social media, 51 terabytes. Okay, and messaging app, web, how much it is? Sensors, IoT, all these devices. Okay. Now, let us assume here computer, local computers. We can have maximum 1 terabyte storage, 2 terabytes of storage. So we are talking only in terms of the storage only, not in terms of computational power. Now, if in 1 minute it is generating 1000, approximately 1700 terabytes of information, is it possible to handle with normal computer? So it is not possible. So there it comes to how to handle these huge amount of the data, that we will call as a big data. How to handle it, how to manage the things properly. So here we can have a definition. Big data is a data that exceeds the processing capacity of conventional database systems or conventional processing systems, that is desktops or parallel computers, HPCs, mainframes. Okay. So data is too big, and most important is how much data that it is going to generate. So in a single minute, this huge amount of the data is generating such that we have to handle very fastly. That is velocity. So volume, velocity, variety of the data. Some, if you take the WhatsApp, most of the data will be text. Some data will be images. Some data will be audio. Some data will be video. So we have the variety of the data. So normal case, if you take DBMS, generally we will expect the text form of the data or ASCII characters of data. But here in big data, we cannot define the data type. So some data will be in characters, some data will be in images. So many types of variety of the data will come. So that's why big data can be defined with the 3 V's. 3 V's. Here one is volume. Huge volume will be generated, 1 V. And second one is velocity. In a single minute, huge amount will be generated. And third one is variety of the data. So some authors will say 5 V's also. Okay, main is 3 V's. Okay, huge volume will be generated in a small time frame, okay, and we need to handle it properly. So how do you these things? So the traditional computing will be failed. So we have the techniques how to handle the data. There we are going to discuss it. So mainly, instead of focusing on different types of architectures or theory, we are particularly focusing on the Spark. Spark is a one platform or software tool where we can manage the use volume of the data, and we can process also. It will provide storage as well as the uh, processing. So previously, it will helps to handle both batch processing, real-time analytics. What is batch processing? Batch processing and real-time analytics. So if you submit the data, you have to get the reply. So when we are paymenting to someone, okay, we will select the how much amount you want to transfer it, and after entering the PIN number through the UPI, you have to get the immediately. So you should not get the response after 2 days. Okay. So in batch processing, what will happen is some tasks. So you are training the model. Okay. You are training the model. So what Google will do is it will collect the all similar tasks. Okay. Once after collecting all similar tasks, it will be submitted to server. So all the application will run simultaneously. So similar applications will be uh, grouped together. Then we will call as a batch processing, real time. And this is the architecture. So within half an hour we will complete the theory. Another half an hour we will have the hands-on session. If you have the laptops, you can work out it, or otherwise I will give the demo. If this computers is okay, you can also use these available computers here. Okay. So if you have any doubts, you can raise at any time. So I will go somewhat quickly to cover the hands-on session also. So the Spark, Apache is a flat provider or developer for the Spark. So it will handle the large amount of the data. So the architecture is like that. So client cluster manager will be there. So it will manage the all nodes. Okay. So each inexpensive computers, 20 GB, 20 GB. So here to combine all these things, we will get the huge storage. Now what will happen is we want to store the 100 GB data set. We have 100 GB data set. Now what we are doing is we will submit this to the cluster manager. Then cluster manager will distribute it. So here we can see five clusters are there, 5 nodes are there here in a cluster, 5 nodes are there. So each cluster we are distributing it 20 GB, 20 GB, 20 GB, 20 GB. So total you will get the 100 GB. And most important one is if something happened here, that is due to the failure of the hardware, if the system goes to the down, so we have to make sure that we can access even if one node goes to the down. That is, we should implement a big data architecture such a way that it has to provide the fault tolerance. Fault tolerance. That is a very important characteristics. If one system goes wrong here, if this node goes wrong, that is due to the failure of the hardware, due to the failure of the software, okay, then what will happen? We cannot access this, okay. But due to the tolerance, the same data will be replicated at the multiple nodes. We can access from the other nodes also. That is the fault tolerance. So we will have the cluster, we will have the application, that is data. So the cluster, this whole system is called as Hadoop cluster. So the whole data will be given to the Hadoop cluster, and this will be distributed. This is a high level diagram. So most important one is unified processing. Unified processing means it can handle the text data, it can handle the image, or it can handle the audio, or it can handle the video data. So different types of data. Structured data. Structured means each column, if you take the tables, that what you have handled in SQL. So if you know the semantic meaning of the data, then we will call as structure. It is a well organized manner. So here it is very easy to manage. Unstructured means we don't know the semantic meaning. So in that case, we will have the streaming means online application, or we will have the simultaneously, even it can be a text. So one end data will be generating, another end data will be processing. That we will call as streaming. So most important is fault tolerance. So if in a cluster, if one system is fails, it has to able to access this data. So fast, because of the many computers will be combined together, we will have the fast processing also. So tackle the diverse workloads, batch processing, real-time processing, and works with your favorite languages. At the most, it is Spark platform is able to support the Scala, Java, Python, R, and many languages. So you can code it. Your application can be coded in different languages. Then the history, how it has started. So map reduce. So the first paper based on the map reduce, this technology has invented at the Google. So map means a given task is divided into small parts. Then we will call as a map. Reduce means once after this mapped tasks computed, the results will be combined. So this technology has been uh, introduced by the Google. Map and reduce. A given task is divided into multiple tasks. After that, we will collect the results. So this type of technology, that is, we will generate the graph planner. So different planners will be there. So depending on the planned nodes will be distributed. Once after computing all these things, we will have the collection data. Even you can in Unix, if you have a lab, we can have the fork and join. If you remember in OS, fork means we will have the multiple threads will be generated. Okay, map means we will have the task will be small task will be created. These tasks will be executed on the different clusters. After that, we will have the like join, we will have the collect means all the results which are executed parallelly, those results will be collected. So map reduce is the main core part development to the Spark. Then we will have the Hadoop. So distributed Hadoop means distributed file system. It's a platform. So normally I have the previously we have seen one example, 100 GB data. So each GP, that is each system, we are going to this 100 GB is divided into 5 clusters, that is 20 GB, 20 GB. We will distribute it. Then we will store it. So this called as a distributed file system. So normally, how do you access the file in normal individual computer? We will have the file pointer f dot read, and we will get the data. In similarly, user does not know whether it is distributed or not. Similarly, he will open the file and he will read the data. So without knowing where it is distributed. Okay, that we will call as distributed file system, Hadoop. Then after the Hadoop, we will have the Spark paper. This in the main problem with the Hadoop is if you want to execute a task, it has to communicate with the hard disk. Assume that we are retrieving the data or we are processing. We have distributed, if you take the Wikipedia, okay, Wikipedia has having 100 terabytes of the data. Now, in specific, that is AI, deep learning, I want to know how many words are there, particularly related to the deep learning. So I have to, what I have to do, I have to count the words. Okay, I have to distribute this task to the clusters. Okay, in that case, what will happen is it has to each time it has to retrieve the data from the hard disk only. It will not utilize the RAM. That is, the whatever the operations that it is doing, it has to first fetch from hard disk to it has to fetch the RAM, and after that it has to count the words. Then after counting it, if more data is there, again it has to clean the data and it has to fetch the data from the hard disk, and again it has to count on the RAM. So the data will be fetched from the RAM. Whatever the operations that you are doing will be related to the your hard disk. So what is the problem with the hard disk? Latency. Latency means the response time. So if you give RAM, it has low latency. As soon as if you request the byte, it will be delivered to the CPU. Whereas in hard disk, it will take some latency because of the hardware. That is, it has to rotate the disk, then it has to locate the sectors, cylinders, if you remember it properly. It has more mechanical parts are there. So all these things are synchronized, then we can able to fetch into the RAM. So the more latency will be there in the disk. So that's why Hadoop is very slow. Now the Spark. In the Spark, what they did is they invented the resilient distributed data structure, RDDD. RDD. Resilient distributed data structure, RDD. So this is a new data structures introduced in the Spark. Because, and it is all operations are based on the RAM. So it does not care about the disk. That will be supported by your internal architecture, hardware. So they invented the RDDD. So it will work on the only on the RAM. So remaining, there are some drivers are there that will taken care by the fetching the data from the hard disk. So almost all 100 times is fast. So Hadoop invented by the Yahoo, distributed file system and processing, and compared to the Spark, Spark is 100 times fast. Okay. So almost all nowadays, if you see the Google video processing, Twitter, almost all every company is using the Apache Spark to manage their huge volume amount of the data. So Hadoop is a framework that allows a distributed storing and processing. Okay. Main problem with this one is it is directly interlinked to the storage, that is a hard disk. So because of that, it is a slow process, and Hadoop is a open source. And the key components, Yarn is a resource management, and we will have the HDFC, so distributed file system, and we will have the map processing, map reduce, that is developed by the Google, and the other data processing. These are the top layer is consider how the application will be, that is task will be distributed, and resource management and file system that we want to manage the data. So we will have, and this architecture will have the master slave architecture, master slave. So one node will receive the all requests. Okay, that we will call as a master, who is managing the actual data, or who is computing the, or providing the processing hardware resources, that we will call as a slave. So it will execute it whatever the instruction that are given to the slave. So the master will receive the request. After that, it will use the map and reduce technique, and it will divide the task, and it will distribute to the, that is, it will give the instruction to the, a single node for managing the metadata. What is metadata? So very important term, metadata. Generally, you will get this question in the interviews also. Metadata. Huh? Huh? Details of the data. Good. Instead of details, we will define data about the data. So if you want to say, a table will be there. In the table, headers will be there, no attributes names. student name, student roll number. These called as a metadata. Okay, actual data is roll number, their names. Okay, and even in the schema, when you are defining SQL schema will define name means string, roll number means integer or float depending on the things. So this type of things we are defining, no, that we will call as metadata. In case of HTML, tags are there, no, that is also called as metadata. It will tells what is the title. So it describing about the title, it describing about the section, it describing about the how to render the your document. Tags in HTML, that is called as metadata. It tells about the data, that is it will gives the meaning to the data. So master node will manage the metadata, where the files are distributed, in which IP, who is having how much storage empty, all this information will have it. And slave nodes are just processing whatever the instructions that will have from the master, those will be processed. Some nodes will have the name nodes as a backup. If some systems will goes down due to the some failures, we will have the backup nodes that will call as a. So this is how the distributed client will send the data to the name node. Name node will manage the like file allocation table. FAT is there, no? File allocation table, NTFS. So these are structures to manage the data about the data. So like name node will manage where the data will be there. If someone is attacked to the name node, we cannot access the data. So we will have the secondary name node for backup purpose. Okay. Name node is going to manage where the data is available. This data node 1, that is one computer. Data node, this all are the total we will have the 8 computers are there. Okay. So each node will act as a data node or processing node. So this is a HDFS architecture. It's a file structure, how the data will be stored. We will have the file name. In block 1, it will have a pointer where the data is stored in block 1, block 2, block 3 and block 4. So here we can observe this B1, here it is stored, and another node also B1 is stored, B2 here and here. So we will have multiple replication of the same data. So to make the fault tolerance, if this node has some problem, is unable to access it, we can access from this node. Okay, B1, B3, B4. Like that, same data is replicated at many places. If due to the disasters, if one node is having a problem to provide the data, we can access from another node. So we can here, if nodes fails, so we'll have the replication of blocks for fault tolerance. This is a structure how we are going to manage the data. Hadoop processing. So here we can observe whatever the iteration of the data read and write, all these things will happen directly on the RAM, hard disk here, hard disk. So main property of the hard disk is persistent, whereas RAM is non-persistent. Even after power failures, or if you are no power is there, after coming the power, you can access the data. That is persistent. Data will not be lost due to the power. Okay. Whereas RAM is a volatile. So once no power is there, we cannot access the data. We are going to lose the data. Whereas hard disk will have the persistent, non-volatile. So the problem with the hard disk is latency. It is slow response. Okay, it will take much time to read and much time to write it. So that is a problem. Now Spark in-memory data sharing. So we can observe here from the hard disk, we will have the iteration 1 that will brought to the RAM. So RAM latency is very low. So quick response will be there. So that's why almost all compared to Hadoop, Spark is 100 times faster than the Hadoop. We will have basically in-memory data sharing or in-memory processing. So whatever the computations that you want to do, that will be data is fetched from the RAM directly. So we will have the software developed that they call as RDD. Now we can see the architecture here. So main Hadoop Yarn and Mesh, Spark Standalone, Kubernetes and Spark Core, that is a data structure distributed RDD will be there, and normal M library, machine library, SQL queries, frames, and languages. It will support some many languages as we discussed earlier, Scala, Java, these are the things. So this is a high level architecture diagram, master slave. So one program will be act as a master, so which will receiving the application. Okay, then that will node call as master, and most important we will have the Spark context. Through this Spark context we are able to access the worker nodes. So when you want to do the any programming, first we need to open the Spark context. We have to. So this is a driver program. So it will manage the all clusters. So it will allocate the information by calling the cluster, what are the resources freely available. All this information will be taken care by the driver program. So which resources are free, where the data is allocated, which servers, all this information will be with the driver program, and the driver program will allocate the resources and it will create a runtime environment that we will call as a Spark context. Through the Spark context, we could able to access the various nodes. So this is a master node and these are the slaves. So in between we will have the cluster manager and we will have the driver program, and where the driver program will allocate the Spark context. Through the Spark context, we can communicate the various nodes. So RDD means resilient distributed data structure, that is invented in the Spark. Because of this data structures only, Spark is 100 times fast. So here assume that you want to count the number of ports are there. So 100 GB data is there. So the data will be distributed different systems. So we will plan it. If two nodes having the data, we will have the two counting. After that, we will collect the all information word count from the nodes and we will have it. So here RDD1.join means this one. It is collecting. It is like a thread 1 and thread 2. In terms of operating system, we will have this thread 1 and thread 2 that are executed by the different computers. And join means we are going to collect the data. After that, you can have the filters. Based on your requirements, you can have the filter, that is, you can manipulate the data and you can display to the user. So most of the system, as we told, Nokia, Yahoo, even Netflix, all these users, even YouTube also is managed with the Spark only. Internally, they are using the Spark. Okay, Spark retail. We can use various applications are there. We can use the Spark in healthcare to maintain the records, to maintain details. E-commerce, Flipkart, okay, Amazon, finance, retail applications, media, that is Netflix, YouTube. So almost all users are been using this Spark because of its fastness. It is 100 times faster than the Hadoop. So the main core part of the this one is RDD. RDD. resilient distributed data structure. Resilient distributed data structure. Like list is a data structure. Okay, list in case of Python, if you have list, array is also small data structure. Okay. Like RDD also one data structure where it will manage the data at the different nodes that will be hidden to the user, and this will directly communicate with the RAM. Okay, we don't dependent on the disk directly communicating the disk. Some driver program is there that will handle the disk fetching. That's why it's a very fast. So to install the Spark, first thing is if you are having Ubuntu platform, sudo means super user, sudo apt, that common command in Ubuntu is apt tool, and install default JDK, Java is required platform, and sudo apt install Python. If you are working on the Python platform, you have to install the Python. If you are working on the Scala, you can install. Then set the Spark, all these things, path, then you can work it. So if you are familiar with the Ubuntu environment or Linux environment, Bash is a terminal. So we have to set the where the Spark has been installed, Spark Home, all these things you have to use. Gedit is a editor like a Notepad in your Windows. Notepad, word editor, Gedit. So where we will write the commands and we will execute in the terminal. Or if you want to install on the Windows, these are the steps. Install Java 8 or later, install the Python, and you download the Spark, Apache Spark. Okay, from this, when I am working on this one, we have the Spark 3.50. Then you can execute the things. If you are any doubts, you can raise. Shall I ask the questions? Small questions only. Huh? So before going to practical session, we'll have a quick recap. So what is big data? Large volumes of data is generated in a time or units of the time. We'll have the variety of the data also. That is different types of the data. Okay. Hadoop is a distributed file system. It can handle it, but it directly depends on the hard disk to manipulate the data. It is directly. Why it is? So in Hadoop, why it is using the only hard disk instead of RAM? Nothing happened. Don't worry. What is the main components in the Hadoop architecture? Master slave component. They will have the two components. One is master, another one is slave. And how the Spark is achieved a good speed up compared to the Hadoop. So through the RDD data structures, resilient distributed data structure. So it will work as in memory. It does not depends on the disk. Previously they used the hard disk, Hadoop. Why they are not directly not dependent on the RAM? So main basic is data is persistent in the hard disk. Even during the computation, if something went wrong means we can recover the data. In case of RAM, if it depends on the RAM, what will happen is if due to the power failures, other things, we cannot access the data. So this is a particularly problem in the uh, RAM. So this recovering of the data and depending on the RAM, all these problems are eliminated through the RDDD data structure. Okay. Let us see how to execute the problems in the Apache Spark. So distributed data structure environment. Do you have any idea Google Colab? So if you are working on machine learning, you can use a Google Colab. It will provides platform as a service, that you will have the all libraries required to execute the machine learning applications. So once after type in Google Colab, okay, you upload a notebook. ఎక్కడ ఉన్నాయి ఫైల్స్ పాత్ పీపీటీస్ అవి ఇవి ఎక్కడ స్టోర్ చేశారు డెస్క్టాప్ మీద పీపీటీస్లో ఉన్నాయి కదా ఓకే ఓకే హాఫ్ అన్ అవర్ stand up, stand up. What is big data? You tell me. Backside, stand up. What do you understand? Can you summarize this half an hour presentation? Huh? Anyone? Sit down. Who will tell? Simple question. What is big data? What is the architecture of Hadoop? What are the components are there? What is the architecture of the Spark? Why we will use the Apache Spark? So the very simple concepts you have to understand. So in Google Colab, it is a cloud service where we will have the platform as service. So we will get the GPU as well as storage, as well as some Python libraries. Previously we have discussed how to install Java, how to install the Python. All these things are being taken care by the Google Cloud service. You don't require to install anything. Okay, you come to the Google Colab. Okay, then after that you load it. So here main thing is you require the Spark. Py Spark means it will supported by the Python. Okay, so we to install it, and in Google Colab, we will have the individual blocks will be there. This is one block, this is another block. So in normally in C language, if you start the executing, your whole code will be executed. But here in Google Colab, we will have the execution to certain block only. Does not you can see after each set of instructions, you can visualize the how the data is being processed. Those facilities are available in the Google. So here I try to install the Python Spark, py Spark with the pip. Pip is a command like apt sudo is there, no? Sudo apt installed, that is used in the Ubuntu. Similarly, we will have the pip installed PySpark. So to execute this block, you have to press this play button is there, no? Like you have to press it. Then you can observe here mouse is there, no? Here you can see visualize the RAM and disk has been allocated. That is virtual computer has been allocated for us. You can see the resources. Okay, system RAM and disk, how much we are utilizing. Okay, even if you in case of Kaggle, you can visualize the how much CPU you are utilizing. So this is a virtual platform that is created. Virtual machine is created for us when we are executing the things. Okay, now we are able to successfully install the py Spark. This is the first step, the package which we required, that you have to install it. Now, so in the session diagram, in the architecture diagram, we discussed that we require the Spark session, that is Spark context. Through that, we could able to access this virtual machine. So the package that are available is in Python is Spark session. You have to import it. This is the code where we are going to create the Spark session. Spark session dot builder, app name hello world, and get or create. So get means if already created means it will be written. If there is no Spark session means it will be created. Okay. Then once after getting the Spark session, through this handler Spark session, we can handle the things. So next step is we need to create the distributed data structure RDDD. So here, for simplicity, I took the 1, 2, 3, 4 words. So I am distributing these 4 words in a distributed system, and I want to count it. Okay. So here data equal to hello world. In this way, I could be able to create it. Now I'm giving Spark context, parallelize the data. So these 4 words will be distributed. And now once after distributed, the data has been stored properly. Now we have to call the application to count it. That is, we have to start the map. We need to perform the computation. Can you remember what is the lambda in the Python? Lambda in Python. Why we will use? Anyone? Completed, no? Python. A function without name we can define. Okay, that is the use of it. So inline functions we can say. Inline function. So what is the advantage of inline functions? What is the advantage? There is no calling will be there. So no stack will be required. There is no calling. There is no requirement of the storing where the to jump to particular place. If you read all these things in the operating system. So here what we are doing is we are recursively calling word. Hello world will be given like X. Then word, and we are using the len to count the number of words. That will be then word underscore length dot collect. So here this length, whatever we created world length, it is a lazy execution. So it will create the map. It will create the workflow map. Map will be created, and once if you call the collect, then it will start the executing the nodes, and it will collect all the data, that is number of ports that is returned from various computers, and that those results will be displayed. Once after successfully using your Spark context, we need to have the stop it. So here we are distributing the data, this part, okay. Then we are making the map here. Then we are executing it. So these are the actions will be performed. Now let us see. So whole code, whatever the instructions in this block, will be executed. So hello 5 words, world 5 from. So generally why we will use hello world program? Generally if you want to learn any new language, generally we will execute small program called as hello world to understand the basic structure of a program. So the first one is we need to create the Spark. The next step is we need to create the data structure. Next we need to create the map. Then we need to have a collect. So once after calling the collect, your data will be executed, your map will be executed. So the map is having, what will happen? We need to count hello world. We need to count the words, letters in the hello world. We need to count the letters in the world. We need to count. So same operations has to apply for every data. So that is taken care by the map. Okay. So that how to count is will be defined here. So that is the advantage of map. Okay. Then collect means it will execute the task, whatever the task is given, that will be executed. Then we are displaying the things. Now let us take another very simple example. 1, 2, 3, 4, 5. So these are the data that we want to parallelize it, that is we want to distribute it, and after that we want to multiply, that is with 2, and then I want to display only the numbers which is greater than the 5. These are the two tasks. You can feel that why we have to use multiply with the 2. So in if you want to rotate an image, or if you want to translate from one place to another place, each intensity of the pixel will have some operations, whether it is a multiplication or whether it is a plus. Plus means we are transforming one object in an image to another place. So plus rotations based on the some rotation formula, we will have some value. If you apply this value to every pixel, then we will have the rotations. So internally all operations will be mapped to the multiplication as well as addition. So this is a very simple formula where uh, every element in the RDD will be multiplied. Then we will have filtering to display only the elements which are greater than 5. Then we will have the RDD.collect, which will be displayed, and finally we are displaying the results. So the results will be in the result, and we are displaying now. So 6, 8, 10, these 3 elements, once after multiplying with the 2, these 3 elements 6, 8, 10 will have the greater than 10. So these are basic programs where we can execute and we can understand how the Apache Spark will work. So first step is we need to create the Spark context. Next step is we need to create the RDDD. Next we have parallelization of the data, that is distribution. Next we will have the map, that is we are going to create the work graph, how do you process the data. Then we have the execution, that is collect. After that we will display the results. These are the main basic steps that are involved in the Spark. So here we have got an idea that we are not doing internal clustering, that is collecting the all computers, how much configuration is there. All those things will be taken care by the underlying Spark core. So we don't need to worry about the various hardware that is available in these things. So we can use high level uh, packages which are available in the PySpark, and we can utilize that. We can distribute it, your whole data, and you can apply the various map functions, that is planning for execution. Then after that you can have the collect. Once the collect is called, that whatever the map you have generated, scheduler, those things will be executed. Then finally you have to stop the Spark context. So we have more number of programs also there. Just I will go through it once. Any doubt? So Google Colab is a cloud service, platform as a service. If you see Gmail, it is what is the service of Gmail? Whether it is a infrastructure as service, platform as service, application as service. What type of service it is? Huh? Application, no? Application as service. Gmail is a application as service. Google Colab as a platform as service, where we can these files are available in my GitHub. Uh, so you can type in Google Ramaya. We are doing work on explainable AI. This is my paper. It is a very good conference paper. SVD grad camp. This is my research work. This one. We can have GitHub. For workshop organizers, I will send a link where you can download all this code. Why it is- Maybe I kept private. So I will enable as a public, and I will send a link to all these programs, okay, where you can execute, so you can understand easily small programs. This learn by do, how to create the Spark. Okay, first this learn by do is a one notebook file where you can understand RDD basic. After that, we will have the frames. After that, we will have the maps, word count, simple programs, data frames. So if you have structure for the RDDD, then we will call as a frames. SQL data, how we will perform all these things, how we will execute machine learning applications. Okay, all these things are available in a one notebook. Another two more notebooks are there. In those two notebooks, I took one big data records. 2 lakhs, more than 2 lakhs records are there of the various with 21 features. We have we can find through that one whether a patient will have diabetic or not. So these applications will be available on the third application using linear regression, and fourth notebook will have the SPM. So 2 lakhs records will be handled through the Spark, and we can apply the machine learning to find the patterns. Then we will execute all these things. So there are four notebooks are there. You can utilize these four notebooks. I will send that GitHub link to your sir, your HOD sir. Then you can ask him. He will distribute it. Okay. If you have any doubts, you can raise. No doubt. సార్ని కాల్ చేయండి మేడం క్లోజ్ చేసి So in final year projects, uh, best thing is you can plan for the Apache Spark to handle huge volume of the data. To find the patterns, you can apply machine learning techniques or deep learning. Those sample notebooks already given in the GitHub, you can execute it, SVM. So what are the applications in final years they are working? For your projects, you can plan Apache Spark to handle the data and to find the patterns that are available in the data, use value of the data. You can implement the logistic regression, machine learning, simple one, SVM, logistic regressions, and even you can work out the ANN also, artificial neural networks, to find the best patterns available in the huge volume of the data. Netflix, so already you know YouTube also. So they are processing huge volume of the data, and they are recommending uh, based on your interest. They are recommending the various uh, files to you. That is various movies in Netflix or various content videos in the YouTube. Those things are being processing huge volume of the data that are managed by the Spark, Apache Spark, and after that we will have the ANN, artificial neural networks, to process or to find the interest of the person based on the previous history. Then we can find the various patterns and we can recommend it. There are huge demand uh, for who knows Apache Spark as well as the this artificial neural networks. For your ideal project, using this recommender systems, which will see the metrics, finding the patterns, what is the future trends, guidelines in the various WhatsApp or Twitter messages. These things, various applications you can work out. Your final projects are earlier, not early, earlier also. It is very good actually. Use applications are possible to develop if you are interested. For coming as a course of your parents or some other external force, no problem, it's up to you. But don't think that in movies you see that hero will be very lazy person. Okay. And finally, at the end of the movie, he will get a good job. We know that. That will normally happen. Good job, good girlfriend. Many things he will get. But in normal life, it will not happen. Until unless you work. Movies, it's a, for commercial purpose, they will do like that. But normal life, you don't expect it. It's only entertainment purpose. So some students will sit back bench, okay, they will crack the Microsoft job or Google, and then you will get the good package and a good girlfriend. Many things you will get. But in normal life, it will not happen. You have to focus, you have to learn. Many things are there. Real life and movies very different. You have to concentrate on your work. So many students, with my experience, I tell you, many students are got the job based on logic. So even if you crack with the test,
Okay, okay.
So to analyze you, they will basically ask the many questions from the project, whether you are worker, whether you have time of BTech. So those things can be analyzed by interviewer. They will know who is working, who is not working. All these things can be analyzed by asking your final year project. You have to work more on the final year project. So according to the trend, you have to do it, plan it properly, execute it.
Completed, sir. Thank you so much, sir. Thank you so much for your valuable words and inspiring session. We truly appreciate the time and efforts you took to share your knowledge with us. Thank you so much, sir. A round of applause for their valuable contribution. Thank you so much. The FDP was very informative and well organized. The session helped enhance our knowledge and teaching skills. Thank you to the organizers and resource person for such an enriching experience. So today's session is closed. Thank you. Sir, belong, sir. Principal, sir. Belong, sir. Session closed and streaming off. చేయాలి కదా చేయలే చేయలే